Hello everyone, happy Saturday. I'm here enjoying my morning, having a fresh cup of coffee. I hope that you've all been having a great day. Let's go ahead and get started. We're going to be resuming with our LeetCode Explore series, and today we're going to be visiting a pretty amazing question, one that I think everyone should be very familiar with because it comes up a lot on interviews, and also it's just a good technique to learn how to use. So let's go ahead and navigate to our LeetCode Explore section. Let's click on the play button and let's go ahead and start with our new question, middle of the linked list. Now let's go ahead and read this and see what the prompt says. So given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay, sweet. So what I want to do here is I actually want to pull up one of my favorite drawing tools. It's called Excalidraw. And what I'm going to do is have these both side by side. And with that, we're going to go ahead and draw each one of these different linked lists so we can have at least an idea of what we're working with. So we have 5 different nodes here. 1, 2, 3, 4, 5. Let me draw the arrows in between them. I just want to make it as clear as possible for people that are watching. And we'll also give these numbers just like we have in the question. Now, if you were to ask someone, like there's a technique in a book that's called Cracking the Coding Interview. It's something along the lines of like, try to do it how a human would solve it, or like how would you solve it yourself, right? If you ask a human to solve this, I mean, we can very quickly identify that the middle here is 3. But I think if you take a step back and think about why do we know the middle is 3? Well, it's because we count all the nodes in the list and then we just divide that list by 2 and we get that middle node. So imagine this was just an array, right? Like what would the length of this array be? 1, 2, 3, 4, and 5, right? Because we have 0, 1, 2, 3, 4. The length is 5. So if we do 5 divided by 2, now at least in JavaScript, there isn't any integer truncation or division truncation, so we'll have to floor that result. And we get the value 2, so then we would just go to index number 2, right? Which would be this one if we were in an array. Now, if we have another list like this where we have 6, so in this case, we have what, an even number of nodes. Right here, we have an odd number of nodes. Let's take it one step further and now give ourselves an even number of nodes. Let's give that arrow there. We would go 1, 2, 3, 4, 5, 6. We do 6 divided by 2, which is 3. And we go 0, 1, 2, 3. So they're returning here 4. Because really, this has 2 middle nodes, right? You can imagine that 3 and 4 are the middle of the list, and it's telling us to return the second one. So just with that first method, we're able to get the answer. So this is the first approach that we'll take, because I think it's valuable for us to go through 2 different approaches. So let's go ahead and code this one up and see what we can come up with. So we're going to need a way to keep the length of the linked list, right? So let list length is equal to 0. And then we'll also want to create a new variable that we can use to iterate over our list. The reason that we do this is we don't want to modify the head pointer that we're given, else we're going to lose the beginning of the list. So we essentially make a copy, something I normally like to call the runner, and I set that equal to head. Okay, so while runner, we'll say list length plus or equals 1, runner equals runner.next. So before we execute that, let's go back to our drawing board here and let's make sure everything's good, right? So we have our runner, which is head, and I'll denote that by using this small triangle here. And every single time we do list length plus or equals 1. So here, list length will be equal to, well, the first thing we do is we add 1 and we go to the next one. We add 1, so now we're at 2, next one. We add 1, now we're at 3, go to the next one. Add 1, now we're at 4, we go to the next one. We add 1, now we're at 5, we go to the next one. We add 1, now we're at 6, we go to the next one. But when we're here, we see that runner is null, so we no longer enter this loop. And if we go back to the previous one where we only have an odd amount of nodes, let's do the same thing again. Come over here, add 1, we're at 1. Here, add 1, we're at 2. Here, add 1, we're at 3. Here, add 1, we're at 4. Here, add 1, we're at 5. Here, we don't enter the loop anymore, so we have a list length of 5. We divide that by 2, and we get 2, which is the node index we want to return, which is 3. So now what we need to do, now that we have our list length, we can go ahead and divide that, right? So we'll say let middle node equals math.floor of list length divided by 2. Now this is going to tell us where we need to end, right? So we can say, we can perhaps even create a new variable and call it let index equals 0. And what do we do now? So here we're at 0. We go to the next one, we're at 1. We go to the next one, we're at 2, and so on and so forth. I think what I might even do is I can set this equal to -1 to start, right? And we'll enter our loop. We can set our runner, like our runner, remember when we finished this first loop, our runner ended over here, so we'll need to reset runner. I'm gonna go ahead and group all these variables together. Let runner equals head. And now we can say while runner, what's the first thing we want to do, right? We say index plus or equals 1 if index is equal to middle node. We can return runner. Runner equals runner.next. Now, are they guaranteeing that we do have a middle node? I don't think they gave us a case of what happens if there's not, right? So I'm okay with returning here, not having a return outside, because it should be guaranteed that we at least hit this condition here, right? So now let's start again from the beginning. Not the beginning, but right here where we have our middle node. So in this case, we know the middle node is going to be 2, right? And our index is -1. So while runner, we add 1 to index, so now it's 0. Is 0 equal to 2? No, it's not. So runner equals runner.next. Come back in here, we add 1, so now we're at 1. Is 1 equal to 2? No. So runner.runner.next. Index plus or equals 1, which is 2. Is 2 equals to middle node? Yes. So we return runner, which is pointing to number 3, and that's our answer. So let's go ahead and run this for some of the different test cases. I'm just going to use all of them, and let's see what we get. Let runner equals head. Oh, it doesn't like that I'm redeclaring that variable. So we have 3, 4, 5, and 4, 5, 6. So let's go ahead and submit this one and see what we get. Do we have to worry about an empty list? We'll figure that out now. Okay, 64.28. So this is a nice solution. And I think that the good thing is it's not too difficult to understand. I think it's fairly intuitive. If you ask most people how to do it, they might say the same thing, to get all the different items in the list and divide that list length by 2, and that'll give you the middle. But we can even do better. But before we move on, let's go ahead and think about the time complexity here, right? We're always, like in the worst case, well, I guess here, this will be n divided by 2, right? We're always going to stop in the middle. But this one, we need to go through the whole thing. So it's almost like O of n plus O of n divided by 2. The larger one wins. The bottleneck really is this linear scan that we're doing here. So we're ending up with O of n, a linear time algorithm, right? And then our space complexity here is really constant, because we're not creating any new space, or we're not requiring any new storage that's dependent on the length of the list that we're given. So pretty good time and space complexity there. I'm pretty happy with that. Before we move on, let me go have another sip of this fantastic coffee that I'm drinking. If any of you all are drinking coffee out there, then cheers. We'll get to this in a second. All right, so if anyone had a sip of coffee, hope you all are feeling a little bit better. Okay, so I like this solution. Frankly, it's not one that I've explored in a long time, because I'm so used to doing the one that I'm about to show you now. So if you're new to LeetCode, probably one of the first patterns you're going to come across is something that's called the two-pointer technique. The way the two-pointer technique works is that, well, you have 2 different pointers that are pointing to 2 different areas in some data store, or in some structure that holds data. In this case, it's going to be this list. Now, all the questions I've done so far normally have it where you have a slow pointer that's maybe only moving 1 step ahead every time, and you have a fast pointer that's moving twice as fast as the slow pointer. Now, there might be some harder mediums and some hard questions that maybe tweak this a little bit, so you have maybe a dynamic sort of rate where, depending on some other conditions, it's moving faster or slower. But in this case here, we're going to be taking advantage of a slow and fast pointer, where the slow one's always moving once and the fast one is moving twice as fast. So what I'm going to do here, by the way, I have a golden retriever, and he gets very slippery on my floor. So if you hear any sort of like scratching in the background, it's because my dog is like slipping, and he doesn't like it. I know he doesn't like it, but he still puts himself in these positions. But you know, that's what dogs do. So anyway, imagine that this one up here is our fast one and this one's our slow one. So let's see what happens. If I move this one up by 1, and then I move this one twice, and then again I move this one up, and I move this one twice, and again I move this one up, and this one twice, which we can't anymore, right? Really, our condition should be, well, what happens when the last one can no longer move 2 steps ahead, right? We're in this state right now, and what's the interesting thing about this state? Well, the interesting thing about this state is that the slow pointer is pointing to the answer, right? It's pointing to the thing we want to be in the middle. Let's see what happens now if we actually give ourselves an even length list. And let's try that whole thing again. So let's say that our condition now is going to be if the runners.next, if the runner is null or the runner.next is null, then we stop. So we're going to move this one, we'll move this twice, we'll move this once, we'll move this twice, we'll move this once, we'll move once here and once here. So now runner is null and we return 4. So pretty cool, right? So let's see how this solution will come up. Let me expand this window. Let me reset this. And I actually want to have this like this so we can still see both sides. So we'll have a let slow pointer point to head. And we'll also have let fast pointer point to head. We discovered that we want to do this while fast and fast.next. And let's make sure, right? So here we can get fast, like in our previous one where we were at 5, fast is true, but fast.next is null, so we terminate. So let's do while fast and fast.next. We can check, let's see, if, or actually by the time that ends, right, we can just do slow equals slow.next and fast equals fast.next.next, and then we return slow, right? So let's see what this gives us. Let's run the code here. 3, 4, 5, and 4, 5, 6. So let's go ahead now and submit this. 59.29. So pretty cool stuff, right? I mean, we've dramatically decreased the amount of lines of code that we need, and this is extremely intuitive in the sense that, like, I think most people can read this and understand what's happening. And this is exactly how it's done. This is how we find the middle of the node, because if you think about it, we know it's going to be the halfway point. So because we're moving this fast one 2 every single time, we're sort of only, like, this one's only ever going up to the halfway point because this one's taking care of going in steps of 2, if that makes any sense. Let me see if I can explain this a little bit better. Like, the slow, if there's like 50 items here, and this thing, the amount of nodes that slow visits is determined by if fast pointer can move anymore. Fast pointer is only going to move 50 times in a list of 100 because it's always going 2 steps ahead. So 50 is determined by, if the slow is determined by how many times the fast will move, that means that the slow will only move 50 times. And it's because it's only moving 1 step ahead every single time, it'll get to point 50, which is half of 100. So you'll end up with the middle of the list. Hopefully that makes some sense. And now that I'm thinking about it, if we think about the time complexity of this, it's determined by how many times this loop happens. This loop only happens head divided by 2 times, right? The length of the list divided by 2. It's only going to run that many times. So I'm comfortable saying that it's list.length divided by 2. Now, in terms of time complexity, I'm not really sure if that, is it okay that we leave it at that? I guess that the time would be O of n divided by 2, where n is the length of the list. And again, our space complexity is constant. So this one offers us slightly faster time complexity and even better readability, less code, which is all nice recipes for a great algorithm. So I really hope that this helped you all understand middle of the linked list. I think it's a really great question. The 2-pointer technique is one that you will see over and over again, I'm certain, all the way even until hard questions. It'll always somehow make its appearance known. And because of doing a question like this, now you have the tools to start thinking about this anytime you see a question similar to this, or a question where you might have to be looking at 2 different areas of a data structure at the same time. So with that being said, I hope that you enjoyed today's video. If you want to see more of this, if this is something that you're interested in, make sure to subscribe to the channel. Make sure to ring that notification bell. I try to do these as often as I can, but of course, as you can see on my channel, I'm experimenting with a lot of new things these days, and I'm having a lot of fun with it. So I hope this is beneficial to you. Leave your comments, let me know your LeetCode progress, and let's just have fun with it. Happy coding, and see you in the next one.